Relays. Some circuits utilize electromagnetic switches called relays. The coil in the relay has a very high resistance, thus it will draw very low current. This low current is used to produce a magnetic field that will close the contacts. Normally, open relays have their points closed by electromagnetic field, and normally closed relays have their points opened by the magnetic field. The contacts are designed to carry the high current required to operate the load component. When a current is applied to the coil, the contacts close and heavy battery current flow to the load component that is being controlled. A relay application in a horn circuit. Battery voltage is applied to the coil because the horn button is a normally open type switch. The current flow to the ground is open. Pushing the horn button will complete the circuit, allowing the current flow through the coil. The coil develops a magnetic field which closes the contacts. With the contacts closed, battery voltage is applied to the horn, which is grounded. Used in this manner, the horn relay becomes a control of high current necessary to blow the horn. The control circuit may be wired with a very thin wire because it will have low current flowing through it. The control unit may have only 0.25 ampere flowing through it, and the horn may require 24 or more amperes. Relays can also be used as a circuit diverter. In this example, the high-low wiper relay will direct current flow to either the high-speed brush or low-speed brush of the wiper motor to control wiper speeds. ISO relays. ISO relays conform the specification of the International Standards Organization for common size and terminal patterns. The terminals are identified as 30, 87A, 87, 86, and 85. The 30 terminal is usually connected to the battery voltage. The source value can be either switched on or off by some type of switch or connected directly to the battery. The terminal 87A is connected to terminal 30. When the relay is de-energized, terminal 87 is connected to the terminal. ISO relays. ISO relays conform to the specification of the International Standard Organization, ISO, for common size of the terminal patterns. The terminals are identified as 30, 87A, 87, 86, and 85. The terminal 30 is usually connected to the battery voltage. The source voltage can be either switched or connected directly to the battery. The terminal 87A is connected to the terminal 30 when the relay is de-energized. Terminal 87 is connected to the terminal 30 when the relay is energized. The terminal 86 is connected to the battery voltage to supply current to the electromagnet. Finally, terminal 85 provides ground for the electromagnet. Once again, the ground can be switched or unswitched. Solenoids. A solenoid is an electromagnetic device and operates in the same way as a relay. However, a solenoid uses a movable iron core. Solenoids can do mechanical work, such as switching electrical vacuum and liquid circuits. The iron core inside the coil of the solenoid is spring-loaded. When current flows through the coil, the magnetic field created around the coil attracts the core and moves it into the coil. To do work, the core is attached to the mechanical linkage, which causes something to move. When current flow through the coil stops, the spring pushes the core back to its original position. Some power door locks use solenoid to work the locking devices. Solenoids may also switch a circuit on or off, in addition to causing a mechanical action, such as is the case with some starter solenoids. These devices move the starter gear in and out of mesh with the flywheel. At the same time, They complete the circuit from the battery to the ignition circuit. Both of these actions are necessary to start an engine.